Highlighter, pen.
Okay, let's start it.
Sure. Okay.
Okay. Hi, everyone. Welcome to the ACI February webinar. Just some housekeeping before we get started. Everyone's going to be on mute for the duration of the presentation. If you have any questions, just type them into the chat box, and we'll try to get to as many as possible after the presentation. So today we've got Nick Popoff, who is also my uncle, just in case you were wondering. He's been at St. Mary's Cement for 32 years, and he began his career as a technical services engineer. In his current role as the VP of Product Performance and Development for St. Mary's, he is responsible mainly to ensure that products that we produce meet and exceed the needs of our customers. He's also serving on many associations and standards committees. Currently, he's the vice chair of the ASTM Tech Committee for Cement C01, the ASTM Committee C09 for Concrete and Aggregates. He's a member of both CSA A3000 and A231, and he's a past chair of A3000, the cement standard. He's the chair of the Products, Standards and Technologies Committee at PCA, as well as Climate and Sustainability Committee. Let me just go on for an hour here before he starts. He's also serving on a lot of ACI committees, number 130 for Sustainability, 201 Durability, 211 Proportioning, 225 Hydraulic Cements, and 233 Slag Cements. Today, he's going to be talking about his first-hand experience with ICF construction and living in an ICF home, where he's seen the benefits outweigh the initial added cost. So without further ado, I will pass it over to my uncle.
Great. Thanks for the introduction. You know, this is for some of my friends in the crowd. I'll do my Johnny LaRue fireside chat presentation started. I don't have the fireplace here because my wife's sitting up by the fireplace. I really don't need this hat. When Richie asked, you know, if there's something that I could present, I've done this one a couple times for the industry here, and I truly believe in the value of insulated concrete forms, but not just insulated concrete forms, concrete construction, because it's so important. The insulation is one thing, but it's actually the concrete that gives it the ultimate quality and the ultimate performance that you're looking for. And so that's one of the reasons why I'm a true supporter of it. Not that it pays the bills, but that helps, of course. So I'm just going to share some of the stories, my story, I guess. And I can't change my screen. How do I do this? Okay. Give me a second here. There we go. Okay, this is my story. In 1989, I bought my first home. It was in the south of Scarborough in a neighborhood they called the Bluffs. Cute little house. It was circa 1949, post Second World War home, and I thought it was great. You know, it was 2 years in the workplace. Earning a salary. The market was going up and up and up in 1989. Prior to that, it was on a steamroll, and I thought that if I didn't get in early and sign up for a mortgage and sign my life away, then there was no way I was going to get into the market. I was going to be shut out of the market. Most people probably feel that way from time to time. Most of you have felt that way, and that was my feeling at the time. Started to hate that house within about 6 months of owning the house. I bought it in 1989. You'll see the peak here. Prior recessions were kind of slight, slow sort of incline, then a slow decline over a number of years. But this 1989 one hurt pretty badly. Within 6 months of buying the house, I was down. I was out 40%. I had 25% down on my house, and I was underwater within 6 months. Wasn't a good feeling, and I just at first I loved that house, and then I hated that house. To make it worse, in 1998 I was asked to move. So from 1989 there was no real recovery. It wasn't a slow decline; it was a rapid decline. It was flatline. So basically, I had to get out when everything was low. anyhow, one of the other things back then was I held on to it for 9 years. I had a $180,000 mortgage, and it was 11.75% interest. So, you know, for some of you right now who are in the market at 3 and 4 and 5% interest rates, back then it was very common to have 11.75% interest. That wasn't a bad rate. So I really started to hate that house. I mean, there was some good to it. I love the fact that it was brick exterior, no maintenance, right? Low maintenance. There weren't really any eaves to it. It was just a basic roof, basic construction, single ranch or bungalow style home, which is pretty good. The bad thing about it, which I started to realize when I started to do some renovations interior, it was a stucco and lathing over paper insulation. It was just paper stuffed in the walls. I guess in 1949, insulation wasn't very advanced. This summer it was very expensive to cool. Basically, the heating ventilation system, the fan blower didn't turn off. And in winter, because the walls were so poorly insulated, there wasn't any sort of vapor barrier. If you didn't have, you know, an air flow around your clothes, you would develop mold in the closets, and it was really expensive to heat in the wintertime. So I really didn't like that house. So I was glad to get out of it. Not happy that I lost a ton of money on it, but I thought, okay, when I moved to Michigan, I bought a really nice home, looked great. You know, it's on a corner lot. It was it was one of the models for the subdivision. 430 homes in the sub, quarter acre lot. It was really nice. It showed really well. Didn't take long for us to realize that, you know, while you have insulation inside the walls, but when you got wood construction on the second level, the upper story, this was a south exposure, this was the west exposure, and it really wreaked havoc in the summertime. These full-length windows look great when you're looking at a home. You walk up to it, you go, wow, right down to my feet, all the way up above my head. But those windows, if they're not well designed, and I hate to say this, you know, I'm not going to burst anybody's bubble here, but windows are your worst enemy when it comes to energy inefficiencies in a house. So I filmed the windows, basically put an interior film on it, did it myself, and it still didn't help. So I had to keep the full shades closed, drapes closed in the summertime. Wintertime, it wasn't as bad, but I did have to keep the furnace, the blower going all the time in the summertime, because even though I had the film and I actually installed this awning on the back deck, even then, I still had to run the blower all the time to get the efficiency, to get the air moving from the basement through the first floor to the second floor. And the two-level deck looked great when you're showing a home. It looked wonderful, 3 or 4 access points to it, wonderful. But the maintenance and the upkeep was just brutal. I mean, I hated that deck, hated the house, and hated the energy. So at some point, in 2005, my wife and I, and there's my daughter, we bought a little chunk of land, and it's 1.7 acres, pretty close to us. And I thought, someday I'm going to build my house. My father did it, my brother did it. I'm going to build a house, and I'm going to build what I want and what I like, and I don't have to buy somebody else's, you know, design. And so it took me, you know, years. So I'd go over there on the weekend and, you know, cut some logs and bring some guests with me. I'd have my cooler and, you know, have snacks during the day, and, you know, just spend all day burning fires and cutting trees down. I know people don't like to hear that, but, you know, I waited. So 2005 to, you know, the later point in time, I knew that I would build at some point. Well, in 2008, I didn't realize that the peak was 2005 when I bought that piece of land. So as it turns out, in 2008, another downturn happens, and it happened. So, you know, everybody remembers 2008. Now I really hated that house too. I didn't hate it as much as I hated it now, because now I was down again in my purchasing, in my value, my asset. People told me it couldn't happen here when I first moved to the U.S. to buy my house, and I said, listen, it can happen anywhere, because people in Toronto told me the same thing, and I lost money there. And yes, it happened here too. So I would argue against the numbers that are presented here in this Ann Arbor index, because when I bought in 1998, the peak actually went up by about that amount, but the drop wasn't to this point. My drop ended up right about here. So from the peak to the drop was about 45% loss for me. From the purchase price, I was about 25% under again. So if I add up my losses at this point, I guess the lesson here is don't take financial advice from me. But if I added up my losses, it's 190,000 based on the interest of 180K at 11 3/4 for 9 years. I lost 30,000 at sale from the purchase price. And I made some of that back because I had roommates. I mean, I was so underwater, and I was so stressed or distressed, financially distressed, I guess, that I actually took on roommates. So I had a full basement apartment and had a second room, and they were constantly rented for basically 9 years. So I made back, 108K over that 9 years, but still, 112K loss. Not horrible, could have been a lot worse. The Wixom house in Michigan, I lost 82,000 in interest, lost 20,000 in the sale at the very, very end, and so the total loss is there about 102K. So I was nearing about $250,000 in 20 years of home ownership. Not a really good story, and a lot of you probably don't have the similar story, but that's my story. So one man's trash is another man's treasure, as they say. Michigan at the time, there are job losses. Michigan lost about 1 million jobs to other states. People were just going anywhere to get work. 2008 was just a horrible time. 2008, 2010, and at that point, I basically said to my wife, "Hey, I did one thing right." And anything that we had in the stock market, I pulled out before 2008. Right around 2005, right around the peak, I saw the big rise, and I wasn't a big stock market guy, but I thought, I'm just going to take my money out. I'm going to put it into secured investments, certificates of deposit, they call them here, similar to the GICs that they have in Canada. And so we hired an architect, and in 2009, and we basically broke ground on what I thought was going to be our dream home in 2010. At the time, the excavator said that this was his third foundation that he had dug in 2010. And normally he would have had 50 to 60 done already at this point. We were the 8th permit in Oakland County. Oakland County is one of the largest counties in southeast Michigan, with a population of 2 million people, I think. And so we were only the 8th permit up to that point. That's how bad the recession was. It was terrible. But fortunately, it was pretty good. One of the things that I thought of, and I've always thought of, is insulated concrete forms. I had a chance meeting with Werner Gregory. Werner Gregory is one of the pioneers of insulated concrete forms. And I'll never forget meeting with Werner, and he was talking about a plastic house, and his first homes were plastic with concrete on the inside. And there's Werner there in his later years. And I met him in Port Hope on my way to do a presentation. I think it was in Kingston at the time. And my presentation was to public works departments to promote concrete pavement, et cetera, et cetera. But Werner had called me and asked, for a meeting. And he said, this is the way of the future. This is the way this is the way construction should go. Segmental blocks with insulated concrete forms. He showed me, he took me back to his workshop where he was making these forms. And it was the precursor to the Blue Max system. And I don't know what happened with that system. I can't recall, but it was it was a great meeting, and I remember his enthusiasm. And he said that the cement and concrete industry really should be promoting this stuff. This is what we should be doing. Forget about concrete paving. Of course, that was his interest. But I never forgot Werner. So when we started building, I said to my wife, we're going to build a concrete house. Well, that wasn't too well received by my wife. She was envisioning something that looked like the Flintstones home, and I had a hard time convincing her what I was envisioning. She wanted a log home. There was no way that I was going to get into maintenance again. I had it with that Wixom house, with the exterior painting every 8 years, with the deck painting every 3 or staining every 3 to 5 years. There was no way that I was going to do any sort of wood on the exterior. So we were kind of at opposite ends at that point. But I did say to her, hey, insulated concrete forms, you can do a lot with the exterior, and I promise you on the interior, I'll give you your log home. And she said, okay, I'll let you do it, but you just have to make sure that I get what I want. Well, of course. So one of the things she wanted, angles. She wanted interest. And so I just wanted a square type of home, rectangular sort of home. No, she wanted angles going off in this direction and that direction. She wanted peaks. She wanted interest. She wanted varying sloping roof lines. And so I guess I did what any red-blooded man would do, is I gave my wife what she wanted. So we went ahead with it. It was very, very complicated, created some problems with construction. Also, when it's a single-story home, she wanted a ranch style, single story. It adds tremendous cost to it. It's easier to go up from a smaller footprint 2 stories than it is to keep spreading out. But we got through that. We had another complication at the time. In 2010, everything locked up. There was no financing. There was no money to be had. All the contractors, their loans were called. All of the building supplies were not extending credit. So because we had put money away, and because this was going to be a slow construction process, I was still in the Wixom home, and I was living in that. I financed it to take some money out of it and to continue building the house. And I had to purchase pretty well everything. And the building supply even wouldn't let me, he wouldn't let me, no one would let me buy anything on credit. I had to give them cash or money transfers, money wires, and then purchase all the materials. So every single contractor that I hired, none of them had any credit or any good credit at the time. They're all underwater. They all owed money. And so I had to purchase everything and pay each and every individual contractor separately. So by hook or by crook, I became the general contractor of the project. And so we broke ground and we started, with the footings and walls. So we use a system called the IntegraSpec. And honestly, it doesn't really matter which system you use, as long as it's insulated concrete forms and concrete and steel reinforced concrete, you're in good shape. I did go with something that I thought was unique, which was the Forma drain system. I'm not sure what other systems there are out there now, but these were stay-in-place footing forms where they form the drain as well. So you don't need the weeping tile system adjacent to it. The forms themselves are the weeping tile. And you actually have connections between the two, and ultimately everything just goes to a sump system in the house. And my sump system is basically in the cold cellar at the front of the house here. So as you can see, it was complicated. It snaked around and went in all sorts of different directions, and it was a little bit of a nightmare, but we went with it. So went up with the walls. First, it was a walkout basement, dropped off 10 feet to the one side, and we went with 11.5-foot ceilings for the basement, and we did 10 for the upstairs. These are the brick ledges. As long as everything's planned and you know what your grade is going to be, You basically set up your brick ledges and you go from there. And we started pouring concrete in September. So here we broke ground in August, and a little over a month later, we were pouring the walls. It took a long time, but it really doesn't take that long if it's a simple design. Unfortunately, ours was not a simple design. Ours was a little more complicated. But nevertheless, 2 lifts, the concrete pour, it was basically a 25 MPa, air trained, and I think at first I went with 50% slag, and then I backed it off in the wintertime a little bit. So that's basically what went into the walls. Mid-range water reducer added on site. Make sure you got good slump to begin with. It was 125 millimeter slump, 5-inch slump to begin with, and then I slumped it up to 8 inches using mid-range on site. I basically did that myself, of course. One of the things I always wanted is to have a pool, but I always swore that I would never, ever, ever own a pool unless it was indoors. And I thought, why not? I'm building the house. What could go wrong with putting a pool inside your house? So we decided to go with it. My wife just wanted the hot tub part. I wanted the pool. Compromise, I guess. So we were running with it, and we put the beams across, and we were ready for the floor joist. And the floor joist, I went with an open steel bar joist system, 4-foot basically separation with the perpendicular purlins, and you'll see that in a second here. It was a different design. I thought it was more efficient, open design. I didn't want the squeaky floors, and I didn't want the movement that you get with wood floors and your 16 or your 18-inch floor joists. So that's what we decided to go with. And these are the perpendicular purlins across that steel joisting system. So 2 months later, I finally received my first order of wood, because I was getting calls from the building supply going, well, where's your order? Where's your order? Where's your order? You still haven't ordered anything yet. And I said, I know, because I'm building a concrete house and I don't need any wood from you guys yet. But once I get going, then, interior walls and the trusses and so forth, I'll be coming to you. So it was, just damp proofing on the exterior, the cloth on over top of the Forma drain system. It's just sort of standard in the backfill with stone once you get closer to it. But that's kind of, and steel pan on the concrete pour for the front deck. And then a cold cellar underneath is what we installed. And so main floor gives you the ability to go up. One of the things that you need to do is you need to make sure that you've got sufficient openings. You have to know where your supplies are. You have to know where your main runs are coming in, your electrical, your water, your cable, gas line came in around the backside. You had to know where utility rooms were, et cetera. This is a set of stairs that were supposed to come down from the garage right here. One of the things, of course, this is, how I built my house, and I didn't build it perfectly planned. You have to plan for some coring, and lots of coring. This one was the worst. This was the footing on the walkout, and I believe it was 40 inches in thickness that I had to core through in the middle of winter. I had to get myself into this hole and drain it every so often to be able to go through it. The contractor said, don't worry about it, don't worry about it. You don't have to worry about coring. We core all the time. But I guess this contractor didn't actually core himself. He hired people to do it, and somebody else paid for it. Well, I was too cheap for that, so I did it myself several times, by the way. I think I rented a coring machine 5-6 times for things that I had missed. So the main floor pour from the second, basically from the basement, ended up in middle of November. And at this point, I'm pushing the guys. I'm saying, hey, winter's coming. Snow's going to be coming. I want to close this up. I need the roof trusses on. I want to close it up. And, don't worry, don't worry, don't worry. we'll get it done, we'll get it done, we'll get it done. And even though I was panicking all the time, I guess the one valuable lesson I learned out of this is take your time, sort it out. Things will work its way out. Although I was stressed like crazy at this point, it worked out fine. And I was amazed, a normal 125 millimeter slump, with 10 millimeter aggregate, with a little bit of mid range, you can back off. Even on the gables, the concrete held in there pretty well. These guys just basically put these styrofoam bucks, I guess they were, the end pieces, in there to keep the concrete from slumping out, but it held up pretty well. It tends to stick to the form pretty well on the interior of the form, so it kind of held up. It didn't slump out on me, so we were pretty happy with that. And then December 6th, we got snow, and it didn't stop at that point. So as you'll notice, I didn't have a roof on. I had lots of snow on the deck. I had lots of crap sitting around, and I was absolutely furious with the guys for taking so long. But I did back off the mix to a 60-40, 60% Portland cement, 40% slag, because you basically just need to cover the tops of the forms. The concrete will hydrate on its own. Insulated concrete forms, it's 2.5 inches of styrofoam on either side, or polystyrene on either side, and it tends to hold the heat real well. And the concrete, held up pretty well. We kept getting more and more and more snow. You'll see, on the top of the walls, there's a lot of snow piled up there at that point. And where I'm ready for the roof trusses, but the roof trusses weren't here yet because you got to put interior walls up. And so I borrowed insulated blankets, and I heated from underneath in the basement, and to clear separate little areas at a time for the contractors. And this is more wood coming on site. So the contractors put the interior walls, and then the trusses could sit on the interior walls. So one of the other things, so I'll get to the trusses and the roof in a second. But one of the things that I found really intriguing is underfloor insulation. To my surprise, the Canadian Mortgage and Housing Corporation did a study of 4 identical homes in Paris, Ontario. And what they did is they had no insulation, and they basically had the temperature above, interior temperature was here, and then they basically had 10 millimeters into the slab, below slab, into the granular, and into the soil. And you'll see without insulation on your slab, you're going to see in the winter months, basically, I guess this is March through May, but the temperature of the slab is essentially the temperature of the soil, and 150 millimeters in the soil. If you just use bubble pack, the temperature differential spreads a little bit, but it still doesn't do you a lot of good. There's still, even though this is 150 millimeters into the soil, it still doesn't spread out as greatly as you want. If you use polyurethane, 10 millimeters into the slab, so the differential from the soil to the slab, the gradient, is about 6 degrees Celsius. And then if you have expanded polystyrene, the differential is about 8 degrees or 10 degrees Celsius. The interior temperature is completely separated. Just above the insulation, which is basically into the slab, the temperature is the same as the interior of the home, which means that you've provided that separation. Not only are you insulating your walls in concrete, but now you're insulating below grade your slab, which makes the living space a lot better, a lot more comfortable. I did put, tubes, in-floor radiant heating tubes in there with these different sections, and I still haven't hooked them up yet because I found that the energy efficiency of the house itself with the ICF walls and the insulation below slab, you can walk barefoot anywhere in your basement and it's still very, very comfortable. In fact, I keep the entire house at 72 degrees Fahrenheit. What's that, 22 degrees Celsius or 21 degrees Celsius, I think. So that's the entire basement, and the main floor is the same temperature all the time because it's like a thermos. Got insulation underneath, insulation in the walls, and then I got insulation way up top in the top of the house. Just one of the pioneers of this type of work of thermal modeling, thermal mass, is Kim Presnell. I think he's still at the University of Toronto. If not, he's about to retire. And I was impressed by his presentation on thermal mass. And his introduction to it was the idea of thermal mass was used by the indigenous people of the American Southwest. In your hot desert climate, thermal mass moderates the indoor temperature from the high temperatures, the peaks, and the low nightly temperatures. And it's that idea where the concept of concrete construction, concrete homes, concrete walls explains the benefit of it. So you take on the average outdoor temperature, and it's cooler during the daytime hours. It saves you energy on cooling, and you displace your peak cooling needs into the late afternoon, saving you dollars during the evening. It's essentially a lot more comfortable overall. The only place you're affected by the sun's rays and the radiant heat from the sun is really through your window openings. Concrete tends to dampen the temperature swings, and the next graph basically shows the benefit of high mass versus low mass. As your outdoor temperature goes high, 25 degrees during the daytime and 17 in the evening, and goes up to 25 and 17, the high thermal mass is this one here. Your temperature may swing down to 21 to 23, back down to 21, 23, but with a low mass, like a typical wood framed with good insulation, you'll still swing from 19 to 25, back down to 19, back up to 25. So it's that dampening effect that the high mass benefit is realized in insulated concrete form construction. This one isn't applicable to a residential home, but is very applicable to interior multi-residential units. If you've got exterior envelope, you dampen from the exterior, and then on the interior, you also dampen from unit to unit to unit. Depends on how people are living in their individual units. So I'll just go past this one. This, I guess, Kim Presnell, Professor Presnell, basically did a research, and he created an energy model for a mid-rise building in Toronto, comparing the heating and cooling demands of a building with high thermal mass and low thermal mass, basically, which is wood, which is the base case. So in his case, he modeled a 6-story residential building, and with that, he was assuming 96,000 square feet, 8,600 square meters, compliant with the 2016 Energy Code at the time, aligned east to west, because alignment is pretty critical. And Kath and I, my wife and I, were very cognizant of that. We wanted to have the least amount of windows on the south and west exposure, and the most on the north and east. North and east. We wanted, in his case, he wanted a 35% window to wall ratio, and he had the high mass and low mass base case. So in his modeling, he basically concluded that by cooling, the energy savings annual cooling savings are 11% over the base case compared to concrete, and 13% on the heating side compared to the base case. And, people have always, this is one of the things that I wanted to do. I wanted to look at that and validate those numbers, right? It was one of those things where I wasn't sure if this is true. I wanted to see the value in it. And so I was determined to construct the home like a normal ICF construction, of course, with the insulation under slab, and have forced air, heating, forced air conditioning, no geothermal. And I wanted to see, for myself, but I'll talk about that in just a little bit. If you have shading and summer ventilation, so you improve on your efficiencies. The cooling demand is 29% less. The heating didn't seem to provide any benefit, of course, because you are getting a benefit from, if you remove the shading and you get heat coming in, then of course it's easier to heat the house than it is, to cool it. And that was one of the things that, you have to do a little bit of a trade-off. So there was also in Kim Presnell's work, he actually had, there's a diminishing return of thermal mass, whether it's 3-inch, 6-inch, 8-inch, 10-inch walls, or 25 millimeter, 35 millimeter. I'm bad on these conversions when it's just inches. I wish everybody was just metric, but as it turns out, your point of diminishing return is somewhere around 25 millimeters or 3-inch, 4-inch walls, I guess. 25 millimeter, no, 0.25 meters. I'll think of that in a second. I think that might be 8-inch walls, 6-inch. Yeah, let me think about this for a little bit. But these are the slab thickness. Basically, the point of diminishing return is 25 millimeters. Where there's a big energy benefit. Lightweight to heavyweight wall construction, there wasn't that much of a benefit to go lightweight versus heavyweight when you're dealing with thermal mass. Lightweight and heavyweight are, of course, heavyweight will be a little bit will be better at storing mass or resisting any sort of movement or retaining the mass, thermal mass. And on the cooling side, they're pretty well similar. There isn't that much of a benefit beyond, at this point, I guess, of 0.25 meters. The biggest thing is glazing. And that's one of the things that our architect said. It frustrated him. He was excited about doing the project. He'd never done an ICF home before. He was excited about doing the project, but he complained that glazing, the glazing industry still had not moved forward, where if you have no glazing at all, your energy efficiency is phenomenal, but you live in a concrete home without any sort of openings. And then as you increase to 20% to 60% or 40% to 60% to 80%, of course, wide open glazing ratio to walls. It's a glazing ratio 1-to-1 for the wall. Then you lose the losses are just incredible. So that was where I was going to try and gain some efficiencies. So I did. And I thought that in the construction of the home, that's me on a tractor doing some backfilling, but I put in the best windows that I could. They were double glazed, thermal film, but I also put in a reflective coating that's built into the windows and to resist any sort of heat rise in the summertime to enable more efficient and effective cooling, air conditioning in the summer. But the one thing I quickly realized is plants need ultraviolet light. So every single one of my plants died. Sad story, another lesson to be learned. So the lesson to be learned from that, on the south side, west side exposure, it's good to have reflective mirrored coatings. But if you want your plants to live, you might want to consider having some of the windows as just normal glazing. But I will say this, the efficiency of the home is completely moderated. The temperature is completely moderated. It could be the hottest day out. It could be the coldest winter day. It's so easy to keep the temperature of the home stable all year long by doing this. Pluses, benefits, or I guess there are positives and negatives, I should say. So most important models are from the most important messages from the modeling from Presnell's work. Thermal mass gives you 10 to 15% energy savings annually. The solar gains versus heating losses, cooling losses, you have to trade them off. And there are internal relative gains, between the slabs and the walls, depending on how you construct the home. HVAC needs, heating, ventilation. I found that nobody was able to size my HVAC system appropriately, according to the Insulated Concrete Forming Association or the Portland Cement Association, when they had their small business and housing, or small buildings and housing um, um, organization. And but they did have this software where you can size your HVAC based on a number of parameters. And you input all the parameters, you input ICF, you input the amount of window openings, percent wall openings on the different walls, whether it's south facing, east facing. You put in, you input the amount of shading, you input where your home is, and it actually kicks out the type of HVAC system required for heating and cooling. And when I took this to the HVAC guys, they said, there's no way, you're crazy. That won't do it. You need a larger unit. And I said, no, you don't, because the philosophy back then, and it probably still is the same now, is you're not going to get a lot of air infiltration. You're not going to get a lot of temperature swings. And therefore, you don't want a higher BTUs unit, and they probably still go by BTUs in Canada. You don't want a large unit because it'll come on and it'll blow air just very quickly and then change the temperature to the set point and turn off again. You'll have a lot of on and offs versus a longer, slower, more moderated temperature rise, which is what you want, or a temperature drop in the summertime. You didn't want to do that. You didn't want to change it all that greatly, that quickly. So that's what I ended up doing, is undersizing it according to the HVAC, and it seems to have worked out very well. The other thing, in the event of an energy interruption, we've had this happen a couple times here. The thermal mass doesn't really, it creates an environment where the building stays the same temperature for a longer period of time. You're not affected. If the temperature goes out for 24 hours or 48 hours, we're not bothered here, because the house will maintain the internal environment for a lot longer. In fact, the year we moved in, it was November of 2012, and we were only on the heat. The heater was coming on, right? And so by the time May rolled around, June rolled around, my wife I wanted to show her, hey, this ICF home, look at how great it is. Look at the energy savings we've got. I even turned on the AC unit. Well, you get those 80 and 90 degree days, you're into 30 and 35 degree C weather. It's going to impact the interior environment. So the temperature was increasing slowly in the house. And after a few weeks, she said, I've had enough. You got to turn on the AC. And I said, okay. So I turned on the AC and I left it for, a week. And she said, the temperature is still hot in here. And I noticed that the temperature had risen a little bit. It wasn't cooling off. And so I gave it another week. I said, just give it another week. I could hear the blower going, but the AC wasn't cooling the house. And so we're into June, late June, early July at that point. And she said, I've had enough. You got to call the guy. And I called the guy and I said, hey, I don't think the AC is working. And he said, that's because I haven't connected it yet. So while my neighbors were suffering with unreasonable, uncomfortable environment on the interior, ours was still tempered and moderated because of the thermal mass. There's ICF benefit, yes, but the thermal mass, I'm confident, was not letting air leakage. It was preventing any sort of air leakage, and it was keeping the interior environment comfortable. And of course, there's all sorts of stories for multi-unit residential buildings. There's this building in Waterloo that was constructed, 100 apartments. Similar thing with the ICF system, and that's what they found in this modeling program was if you just considered in the modeling program itself, if you just considered R value, R factor, it doesn't capture the benefit of the lack of air infiltration and the benefit of thermal mass that you get with concrete construction. So you cannot design by R factor alone. That's the key with ICF, and that's the key with concrete. Because based on their models for this particular building, the total cost is about the same. But I know that it's not. So what I did is I asked my neighbors in 2019, these are 2019 numbers, and yes, I took the heated conditioned space that my neighbors have and what we have. And so we have 11,600 square feet. It's a very large home, as you can tell. My first neighbor is 4,800 square feet. He keeps his basement at a similar temperature. Both my neighbors play games with the daytime, nighttime temperature drop. When they leave, they change the temperature. I don't. I just leave it the same temperature all the time. I don't change it. I don't want to change it. I don't have to change it because it's an ICF construction with concrete walls. So when I did a comparison against the neighbors on their gas bills and their electrical bills, I found that I was basically for cooling during the summer months, I was 40% of their electrical load based per square foot. And on heating, compared to neighbor one, I was 59% of his bill per square foot, and I was 46% of my other neighbor across the street. So both these homes were custom build homes. They were 2x6 construction with energy code. We built to the same energy code, R50 in the ceilings, and I'm still approximately 50% of their energy demands, whether it's gas or whether it's electricity. So I was surprised, I was shocked, I didn't expect it. And basically our bills are about the same, even though I've got a lot more square feet. I'm double the square feet of this, I'm triple this one and double this one, and our bills are basically about the same demand for gas and for electricity. So the other great benefit is you can't hear anything. You hear it through the windows, but you don't hear the trains, you don't hear noise. It's very, very, very quiet. This is the second to last point, and I'm pretty soon to wrap it up here. I know I'm running out of time. But resiliency is the new sustainability. A lot of people have heard about the U.S. Resiliency Council or resiliency, how resiliency should be considered a benefit. The problem was, according to Evan Rice, and he's the general director of the U.S. Resiliency Council, he said LEED certified buildings are designed to have a low impact on the environment, but the problem is, and that was realized in Superstorm Sandy, but LEED certified buildings, the way that LEED looks at buildings, is not designed for the environment having an impact on the buildings. So you can have you can build so that you have a less of a demand on the environment, first cost or first design, but the environment can wreak havoc on you. And there were a tremendous number of deaths. There was $71 billion in damages, $16 billion to $22 billion in losses, a lot of 8.5 million homes without power, greater than 10 million cubic yards of debris created from Superstorm Sandy. One of the greatest examples of this is Nashville and New Orleans were before 2006, before Katrina hit. We're on a similar sort of GDP growth curve, and as soon as Katrina hit, it dropped dramatically, and it never recovered, and probably never will recover, because that's the problem with resiliency. Resiliency is a problem with building towards and being environmentally friendly versus building with resilience in mind. The problem is the damage can be so severe that you will never recover and it never comes back. And that's what happened between these two cities. There are other underlying sort of thoughts, I guess, or ideas behind it, but both communities, music oriented, both communities very, very popular with tourism. One suffered greatly and continues to suffer, and the other one that didn't experience a major event like Katrina continues to thrive. So I don't argue that you shouldn't look at the green side of it, but you should also look at the resiliency side of it. And that's one of the things that the Resiliency Council does is they look at the geometry and the construction. They look at how it would react in a major event and how it would behave in a major event, and they give them ratings for that. So there's the problem is with whenever you have a major event with a wood story frame compared to a concrete frame, the concrete frame will get a 3 to 4 star rating with the Resiliency Council. The 1 to 2 star rating for a 5-story wood frame basically says that you're almost at a complete replacement with a major event. And that's one of the things with, you can have non-structural damage where you can repair things, but and you quickly bring it back again. So that's where a concrete construction will allow you to reset things, reorganize things, rebuild things, replace windows. But most often, those buildings that have a poor rating won't recover. They'll suffer severe damage, and it will take them more than a year to come back. Buildings that have a high rating, a 5 rating, 5-star rating, will come back very, very quickly. So modern codes basically are minimum codes. Resilient-based designs is what people should be looking at and should be considering. We don't have that yet. It's not very popular within the rating systems. The U.S. Resiliency Council is trying to establish a platinum, gold rating based on the construction, the design, so that people can understand that the value is in resiliency as well as building green. We're still behind the curve in Tokyo. People are willing to pay more for LEED buildings. Tenants are willing to pay more for LEED certified buildings in San Francisco, but they're not willing to pay more for buildings that are more resistant to catastrophic events. And so that's the mindset. And mindset is in places like Tokyo, they're willing to do that. They're willing to pay more for it. They don't pay more for the green side of it. They're willing to pay more for the resiliency side of it, the safety side of it, the comfort side of it. Anyhow, just a list of the coalition members for the U.S. Resiliency Council. Okay, just to finish off, almost forgot, we did finish the home. As you notice, it's brick exterior, aluminum. I did give my wife a little bit of wood out front, but it is covered underneath. And then the rest of it's all stone and brick. That's looking from the back side of the house. The deck is concrete, the back patio is concrete, the driveway is concrete, the walls are concrete, and my wife got her log cabin on the inside. Of course, there's insulated concrete forms behind this, and keeps it nice and comfortable. And we did finish the pool, by the way, as well. And in the gas numbers that I presented earlier, I discounted the pool because, you know, I didn't know how to compare that to the neighbors. So that was actually thrown into the gas calculation. I'm still that much more efficient in my energy consumption in the house, where I calculated my payback on the entire home is 10 years, and I'm 8 years into it. So I think that's it. Elaine, are you still there?
I'm still here, and we do have, can you hear me, Nick?
Yep, I sure can.
Yep. We have one question that is on the board right now. Did you use air and trained mix in the walls?
I did use an air and trained mix in the walls. Yes, I used 25 MPa air and trained in the walls.
Okay, thank you. Don't
Yeah.
have any other questions right now.
Just before you keep going, maybe it's a good time to, I guess, point out the difference between the mix design that you used and what a traditional foundation concrete would be, because you said you used 10 mil stone, your slump was about 200 millimeter or 8 inches, and that's basically to accommodate the ICF forms, right?
Yeah, that's right. Just to be able to get in and around the forms and drop, we did them 5 to 6 foot lifts.
Cool, thanks.
Yeah, footings. So I use 25 MPa in the footings as well. I know the code, doesn't require that, but I figured 25 MPa. People ask me did you put in a higher mix design? Not really. I mean, I didn't ask for anything more special. I just knew that, the concrete producer was going to give me what I ordered, and that's what I ordered. By the way, on one weekend, Richie and his brother and my other nephews helped me do this deck. I don't know if you remember that or not, Richie.
Oh, I remember that. Yeah, there was some yelling. Let's just say some yelling.
There's some yelling. Yeah.
Once it starts going though, it's pretty easy to do.
What's that?
There are a couple other questions, Nick. Did you run into indoor humidity issues during the initial concrete curing?
No. Well, it took me 2 years to build it, so we didn't really have that sort of an issue. But the walls are so tight, the ICF is so tight that there was no issue with respect to humidity. I will say this. The humidifier on my furnace or on the forced air system hardly has to work at all because there's so little air infiltration that we have decent humidity here in the winter time. Very easy to keep it very well humidified.
And there's one more question, but I think you got to that one. What is the percent reduction in operational costs compared to your neighbors? And I think you had that slide already up there. So that
Yeah,
took care of that question.
Yeah, it's about 50%, and I was absolutely shocked. I got to tell you, I wasn't expecting it. I saw Kim Fresnel's made a lot of sense to me. 13, 15%. If I can get 20%, would have been excited. And I had to run the numbers over and over and over again, and I was just shocked that it was 50%.
That is all the questions we have for now. So, Richie, it's up to you.
Cool. Yeah. Thanks a lot. That was a great presentation. There's lots of information in it, and it's nice that you get to put a personal spin on it, where you were losing for years in the housing market, and you've finally done something right.
That's right. This house I like.
Yeah,
this one I do.
Perfect.
I hated the other ones.
So, thanks everybody else for attending. I just want to say that we will be posting this recording on our YouTube channel, so you can check it out there, the ACI Ontario page. We'll also have some upcoming events. So on April 18th, we will be having the golf tournament. It's just going to be a shotgun start with a box lunch, and I think, Alan, correct me if I'm wrong, I didn't write down how many people can attend afterwards. I think you said we can have up to 20 people on the patio if it's open.
Yeah, that's still to be determined. But yeah, it's just to correct you. I think you had said April, but it's going to be May the 18th, the golf tournament. We usually have between 60 and 70 attendees. There'll be some more details coming out on the website pretty soon, and also some emails to let the membership know of what's coming up.
Yep, and our next webinar will be it is April 18th or 20th for
That is correct.
Technologies. So thanks again, everyone. Thanks, Uncle Nick.
Thanks, everybody.
Thanks, Nick.
Have a great day. Stay warm. Be safe.